Hello everyone, we are Group 6. I'm Chen Youming. We will present the technology report for the Yuheng Road emergency slope restoration works. Here is the outline. I will start with the background and emergency nature. In September 2023, Hong Kong experienced an extreme black rainstorm that triggered a severe landslide along Yuheng Road. As you can see from the photos, large volumes of debris slide down the slope, completely blocking the carriageway and creating immediate geotechnical and public safety hazards. Due to the seriousness of the accident, the Hong Kong government initiated urgent restoration works. The priority at the stage was to remove the debris as quickly as possible, stabilize the effects slope, and restage traffic access. Because this is an emergency project, the works requires rapid mobilization, a strong, safety-led approach, and very tight coordination among multiple government departments and engineering disciplines. The time-critical nature of the situation also means that the planning process had to be highly structured, ensuring proper risk control and effective project oversight from the beginning. Next, I will talk about the key task management framework and report structure. The restoration works involve several key tasks. These include hazard isolation, rapid debris clearance, geotechnical investigation, temporary slope stabilization, partial traffic reopening, and finally long-term reinforcement leading to full restoration. These activities need to be organized into clearly defined phases and, wherever possible, carried out in parallel to shorten the overall restoration timeline. This project planning is guided by the preamble guides, focusing on knowledge areas such as scope, schedule, risk, communication, procurement, and stakeholder management. The project is also implemented under the Hong Kong Government General Conditions of Contract, together with the relevant GEO and Highways Department technical guidelines, which provide the engineering and safety standards required for emergency slope works. The remaining parts of the technical reports are structured around this framework. We begin with the development of a work breakdown structure to define project phases and activities. This is followed by the AON precedence network diagram, which models the logical relationship between tasks. We then conduct critical path method analysis to determine the controlling sequence and the overall project duration. Finally, the report includes the planning outcomes, the schedule modeling results, and recommendations supporting the effective execution of the restoration project.
For the work breakdown structure, we organized an emergency slope restoration project work, so a work breakdown structure is generated to encompass necessary work scopes in order to deliver the project in a rapid manner while catering to the safety needs. The WBS lays down the structure of the project, covering 5 areas: the emergency response, the site clearance, site assessment, short-term repair and partial opening, and finally the long-term reinforcement and full restoration. The first work package is emergency response. Immediate actions required to stabilize the slipped slope caused by the massive landslides are under this work package. It emphasizes on the coordination between emergency response teams, such as the police, fire service department, highway department, and civil engineering development departments. It is necessary to organize the emergency response teams of this department in order to control the scenes of accident and prevent further collapse of the slope. Secondly, the work package is site clearance. After the situation is stabilized, under safe conditions, for example, the chance of further slope collapse is low with site assessment by professional personnel, site clearance can be carried out. Site clearance consists of works such as removal of debris, fallen trees, unstable materials, and damaged facilities like lampposts or drainage pipes, or any obstacles to safe access. For area with potential further collapse, This area has to be isolated and be kept clear from site clearance team until the area is assessed to be in stable and safe condition. The clearance of traffic road is also to be carried out under this work package. After the site clearance, it is the site assessment stage. In this work package, it consists of site survey, geotechnical investigation, and evaluation of slope safety, targeting to obtain details of geotechnical and structural data of the concerned slope area in order to prepare for the upcoming short-term repair design and later on the long-term reinforcement. So the next stage is the short-term repair and partial opening. Temporary stabilization measure will be conducted under this package. For example, shotcrete and soil nail will be in place to provide short-term structural strengthening of the slope. This is to allow previously affected infrastructure such as road and footpath to be reopened and resume limited functionality. And finally, the most complicated work package is the long-term restoration. This stage takes the most time because the detailed planning and full-scale restoration will be carried out. Design work include in this work package for permanent slope stabilization. Stationary approval will also be required to be obtained in this work package. Design works including deep foundation, engineered drainage system, slope retain works, which guarantee long-term safety. After long-term restoration work, the infrastructure will be reinstated permanently. Finally, there will be compliance check and inspection with relevant authorities in order to ensure the work meets the regulatory requirements before completion of works and full release.
Okay, hello, Professor. My name is Youle Yang, and I will introduce the project network diagram. The project network diagram illustrates the logical sequence and interdependence of all tasks in the landslide emergency response project. Based on the WPS breakdown and Hong Kong's established emergency response procedure, the network adopts a safety-first structure in which early-stage action must occur rapidly and sequentially to stabilize the sites. The AON diagram shows that emergency mobilization, site isolation, and initial inspection from the essential starting chain enable debris removal, access clearance, and subsequent geotechnical assessments. As the diagram progresses, the actions feed directly into two parallel tracks. Temporary slope stabilization works and initiation of permanent design tasks. Due to their strong independence, the permanent work covering drainage, slope foundation, erosion control, utilities restoration, and statutory approvals follow a linear path step by step. The sequence then transitions into construction stage, where tasks such as slope foundation preparing, drain channel construction, utilities restoration, pavement reconstruction, and erosion control must be executed in strict order. The resulting critical path extracted from this network highlight the essential chain from emergency mobilization through the permanent work completion. Any delay among these paths would directly extend the project's total duration. That's the end of my part. Thank you.
My name is Zhang Sijia, and I'm responsible for main body, the narration of the PDM diagram and the critical path diagram. As shown here, this path, which is the longest path of the project, with a duration of 150 days, is identified as a critical path. The features of critical paths are that both free flows and the total flow of each activity on the critical path are 0, which means that any delay of activities on the critical path will lead to delay of the whole project. As for principles of time estimate and precedence of activities, we refer to project management body of knowledge guide. And there are three main aspects need to be considered. Firstly, risks need to be considered are weather and recurring of landslide. And secondly, coordination with government and different departments, such as getting a warrant or permission from the government for the foundation. And thirdly, precedence relationships ensuring logic, safety, and efficiencies.
For recommendations, communication and coordination is very important in the project. Conducting regular meetings is the most direct method to keep the stakeholders familiar with the project status and updates. Different parties can coordinate on the meeting and allow parallel working to speed up the construction process, and to utilize resources and allow contractor to have a better planning for execution on works. On-site progress monitoring is also very essential. No delay is allowed on a critical path. Adequate monitoring works shall be arranged to maintain better progress control. We should also allow parallel execution on works when it is feasible and safe. It is suggested to utilize real-time monitoring device in this project. Instant data and information transfer can have a faster response to on-site works. Modification or rectification works can be done earlier before the issues become apparent. During the construction process, the traffic arrangement shall also be properly arranged. Regarding the location of the site, there are only 2 driveways available for traffic users. During the construction work, temporary traffic arrangement must cause inconvenience to the public. It is important to assess the traffical use of the driveway and to minimize the implication to the public while proceeding with the construction works smoothly. To conclude, the proposed planning work is feasible and workable in delivering the emergency works. The critical path duration is 150 days, which aligns with the HKSAR government request to reopen the road as soon as possible. The program reflects the actual situation and can be executed efficiently and safely without delaying. The project details also comply with the regulations established from different authorities. The proposed planning approach provides a reliable and practicable basis for implementing the emergency restoration works. And here's our reference. And this is the end of our presentation. Thank you for watching.